Welcome back in this video series by Sagar Kadam Sir Engineering Academy that guaranteed you will clear a very difficult concept of mechanics without any doubt. Now we are discussing circular motion. In this video we are going to discuss superelevation and banking of road. So when car moves along a curved path, we just discussed in last video there is a skidding. Skidding means between road and tire friction develop, and road and tire friction develop, and therefore due to that friction wear and tear of tire take place. So due to skidding it will damage the tires. Due to overturning, what happen? As car come on outer wheel only, and that will create a discomfort to passenger. When car moves on a curved path, as car is moving on a curved path, it come on outer wheel, inner wheel, outer wheel like this. So that will create discomfort to passenger. Getting what I am saying? So due to skidding, there is a wear and tear of tire is there. Due to overturning, create discomfort to passenger when it moves along a circular path. We find R1, R2 in last video. So R1, R2 not same. Means when car moves even safely on a curved path, a normal reaction or pressure develop on both tires are not same. As tires are designed to get an equal pressure. Here uneven pressure also damage tire, and therefore it become necessary to provide a banking of road. A term we use, banking for a road and super elevation for a railway track. So what is banking of road and super elevation? So as we have this as a flat curve. As center on this side, this is outer edge, this is inner edge. When outer edge is raised above the inner edge, this is inner edge, and this outer edge is raised above the inner edge. Understood what I am saying? Outer edge is raised above inner edge. Suppose this end is here and join this. Okay. By how much amount it is raised? As by how much amount it is raised is called as super elevation applicable for a track. Getting anyone? And at how much angle that road is constructed, outer edge of that road is raised above the inner edge. By how much angle? That called as angle of banking. That is called as angle of banking. Understood what I am saying? Is it clear? Super elevation applicable railway track where outer rail is raised above the inner edge. By how much amount called as super elevation of track. And angle of banking is applicable for roads, okay, where outer edge of road raised above the inner edge. And when we construct such road, as there is no skidding, there is no overturning, equal pressure on tires, and that will use a comfortable travel to that passengers inside that car. Is it clear what I am saying? So this is use of as banking of road in case of road construction. So once road is banked, how much velocity for that particular road at which that car will move without skidding, without overturning, giving equal pressure on both tires and comfortable driver is comfortable to the passengers. That is called as design speed. So here we are going to derive expression for design speed. Okay, so for that I am going to draw FBD first. So car is moving on this curve path, but curve path is not flat, is banked. Okay, as weight of car vertically downward. Understood? We have to resolve is inclined plane, therefore we have to assume this as x. So resolve this weight parallel to plane and perpendicular to plane. This is 90 alpha, therefore this is 90 minus alpha. So this component is W cos 90 minus alpha, and we know that cos 90 minus alpha is sin alpha, and this is W sin 90 minus alpha, 90 minus alpha, and we know that sin 90 minus alpha is trigonometry is cos alpha. So here we resolve it. There is normal reaction R, and when car moves with design speed, as there is a centrifugal, whenever car moves along circular path, it acted upon by centrifugal force W by G, V square by R. Just like weight acts vertically downward, like that centrifugal force always horizontal. Understood? Now we have to resolve this centrifugal force parallel to plane and perpendicular to plane. So this component, we want this angle for resolution. This angle horizontal and inclined. How much angle between horizontal and inclined? It is alpha. Same here, angle between horizontal and inclined is alpha. And therefore this component is W by G, V square by R, cos alpha. And W by G, you know that theory of resolution is angle with that is a cos. Angle with this direction, therefore this component cos. Angle with this direction, this component is cos, remaining is sin. Understood? Is it clear? So here we complete FBD. Now there is no friction. Why? So this is a very important point. Whenever car moves on a bank road, okay, as when car moves on a flat curve, as immediately centrifugal force acts, and to balance centrifugal force, friction develop. Getting what I am saying? And therefore friction develop means it will damage tires, wear and tear of tire is there. But on a flat curve, on a bank road, when centrifugal force pulls the car away from the road, to balance this component, there is a W sin alpha, a component of weight. So here to balance there is no weight, weight is there, vertical downward, but this is not going to balance centrifugal force. There is a friction, automatically develop to avoid that skidding. But in this case, skidding never take place because there is a balance, no friction. Got it? Why no friction? Because to balance this component of centrifugal force, there is a component of weight. Okay? Got it? So let's derive the formula for design speed and alpha. So summation fx equal to 0, I am going to use sign convention now, not balance word. So only these two components I am going to use, this sign convention for x, right positive, left negative. So it is a W by G, V square by R, cos alpha, minus right positive and left negative, W cos 90 minus alpha is W sin alpha, W sin alpha is equal to 0. So here W by G, V square by R, cos alpha is equal to W sin alpha, W get cancel, V square by RG is equal to sin alpha by cos alpha. So V square by RG is equal to what? Tan alpha. This is an important relation, and from that let's get expression for velocity. So here we have velocity as velocity V square is RG tan alpha. So V is square root of RG tan alpha. So this angle of banking and radius of curvature gives us design speed on a curve path. It will give what? Design speed on a curve path for which there is no skidding, there is no overturning, there is a comfortable travel, equal pressure on tires. This is called as design speed. Get it? What I am saying, understood? A derivation clear? And how to get tan alpha for using design speed? Tan alpha is V square by RG. V square by